In this video, we are going to take a break from object-oriented programming for a few minutes, and we're going to talk about how to correctly generate random numbers in C#. We're going to talk about the difference between truly random numbers and pseudo-random numbers. And don't worry, we'll come back to object-oriented programming soon. But the reason I want to talk about this is because it's very common for beginner programmers to run into some bizarre quirks involving the random number generator in .NET. And it leads to a lot of questions on Stack Overflow. One of the most common questions that I field on Stack Overflow is about random numbers. And we're going to need this for our little hangman class. So I figured this would be a good time to look at it. So let's look at an example. Let's just go back to our hangman code here, which I have repurposed to have some random number code in it. And we'll just get right into it. Let's just step into this code. I have a method here that prints out a random number. It does it 100 times. You can see I've done this in a loop. And we're just going to step in here and see what it does. All right, so I'm creating a new random object. This is an object that's built into the .NET runtime. It's system.random. So I create that object. And then here's our first quirk. C#, as we know, has this general pattern of things that you might think would start at 1 actually start at 0. So if you say, I would like the next random number, and then you give it the number 10, then it will say, I'm going to give you a random number between 0 and 9. So from 0 up to 10, but exclusive of 10. Many people think that this gives them a random number between 1 and 10. It does not. All right, so we'll produce the next random number, and let's just write it out. All right, so we've called print random number once, and let's see what it did. It printed out 4. All right, let's do that again. We'll just keep on stepping around this loop here a few times. OK, and so what's it done? Well, it's printed 4, 1, 9, 4, 8. OK, looks like it's working. I'm going to put a breakpoint here after the loop runs, and I'm just gonna hit run, and let's take a look at the output. All right, so it started with 4, 1, 9, 4, 8, and then 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5. That could be random, but I'm thinking it's probably not. The odds of getting hundreds of oh wait, it's no longer 5s, now it's 9s, and then it's 7s, and then it's 1s. But things seem to be coming in long bursts here for some reason. That is really weird. OK, well, I'm not sure what's going on here, but let's try something slightly different. Let's try getting a random array. And this time I'm only going to do this 2 times, right? So I'm only going to do this 10 times. So I'll step into our method here, and it's going to create a new array of 20 integers. So they start off, if we take a look at this, of course, all is 0. Then we're going to go through our array, and every time through the array, we'll create a new random object. And then we'll say, once again, I would like a number between 0 and 9. And I'm going to fill that into the array. And if we take a look at our array here, then we can see that, OK, well, we started 4, 7, 4, and that's as far as we've gotten. The rest are all still 0s. Right? But we could keep on doing this, and that would be just fine. We would keep on filling it in. So yeah, looks like this code is working fine. Let's step out. So we'll call getRandomArray, and then we'll use string.join to say, well, here's this array. Give me all of the contents of this array, strung one after the other, separated by commas. So we'll write that out. And it's 4, 7, 4, 3, 3, 2, 9, 9, 9, 9, 9, 9, 9, 9, 9. Something is going on here again. I'm going to put a breakpoint here, and I'm just going to let this run. And what's happened? Well, we got our 4, 7, 4, 3. It seems to have started off random, and then suddenly it gets stuck on 9 for a while. And then it seems to get stuck on 1 for a long time. And then it seems to get stuck on 4 for a while. OK, something definitely odd is going on here. I'm going to call a method that I'm going to call better getRandomArray. Let's take a look at that. This looks like exactly the same method. What's the difference between this method and this method? Well, you have to be pretty observant to notice that the difference is I have taken this line and I have moved it up to here. So I've taken the creation of the random object out of the loop. So let's see how that could possibly make a difference. I'm going to just run through this loop, asking for the next random object, asking for the next random object, and so on, the next random number. And I get 9, 4, 2, 9, 4, and then, oh, well, I haven't filled in the rest of the array yet here. So let's just step out here. And then once again, we'll write out the array there. And we got 9, 4, 2, 9, 4, 1, 8, 4, 1, 1, 3, 2, 0. It looks like this thing's random the whole way. So that looks good. I'm just going to put a breakpoint here, and then I'm going to hit go, and we'll get the next 9 of these things. And so now let's take a look at this output. So we had our random one here, and then we have 50979150. OK, so that looks pretty random. And then we have the exact same one again, the exact same random array, and then it changes. Now we have 3, 4, 4, 9, 7. All right, that looks random. And then we have 5 times that random array again. So we're no longer getting these long runs of the same number, at least, but now we are getting the same sequence of random numbers over and over again. Clearly, this is still not actually random. So what's going on here? Well, what explains these observations is that the sequence that we get is actually pseudo-random. And by pseudo-random, I mean not random at all. It merely appears random. The way the random class works is there are a large number, there are billions of possible sequences of numbers, and one of those is chosen. Each sequence itself appears random if you look at it. But it's actually determined. It's actually chosen, that sequence of random numbers. Now, how is it chosen? Well, we choose which of the several billion sequences we want through what's called a seed, which is a number that we pass into the random class that says, I would like this particular pseudo-random sequence. So let me call getSeededRandomArray, and we'll take a look at how that works. So if I step into getSeededRandomArray, this is exactly the same as the previous method, except that now I've said, I want random sequence number 1234. And now, every time, I will say I would like the first 20 numbers in this sequence. Right? And we'll just step out of here. Right? We call this thing 10 times. Like so. Right. And now if we look at the output here, we can see we got the same sequence every time. So 3, 8, 3, 9, 3, 9, and so on. And then again, and then again, and then again, and then again. So we're getting the same sequence every time because we have the same seed every time. But what explains this here, how we get one random sequence, and then we get a different random sequence for a while, and then we get a different random sequence for a while? Well, you always get the same sequence if you start with the same seed. If no seed is provided, then the operating system chooses a seed, and the seed that it chooses is how many milliseconds has this machine been on? Which means that if you ask for 2 sequences during the same millisecond, you will get the same sequence. Okay. So now we can see why each of these different versions of this algorithm produced the results that they did. Right. This version, print random number, every time we called it, it created a new random sequence, and it fetched the first number from that random sequence. But if we asked for the first number from random sequence 1234, or however many milliseconds this machine had been on, obviously a much larger number than that, then we would get 5, 5, 5, 5, 5, 5, if that happened to be the first number of that sequence. When the next millisecond ticks over, then we start getting a different number, right? Because now we're looking at a different sequence. Same thing here, right? Every time we asked for a random number, we asked for a new random object, and we picked the seed. This one was different because we asked for the random number up front, right? Or we asked for the random number generator up front, and then we said, well, I would like the first 20 numbers in this sequence, right? So every time the millisecond clock ticked, we would get a different sequence, but we would always get the same 20 numbers if it were within the same millisecond. How do we actually do this? What's the right way to do it? Well, let me first describe some bad solutions that I see quite often. The first bad solution is do nothing. Just live with this bad behavior. If sometimes your code produces the same random number generated 50 or 100 times in a row, you're just going to have to live with that non-random behavior. That seems like a really bad idea. Don't do that. The other thing you could do is you could write programs that create multiple instances of the random class, but that you make sure that between creations of the random class, you allow a certain number of milliseconds to go by so that the thing is seeded properly. That's also maybe not such a good idea. It seems like a bad idea to deliberately slow down your program just to work around this quirk of the random number generator. Another thing you can do is you could generate your own seeds. Right? You could say, well, every time I need to create a random number, I will just create a random seed and use the random seed to seed my random number generator. But now we have a chicken and egg problem. If you already have a mechanism for generating random seeds, then you don't need a random number generator. Why would you use random in the first place? You would just use whatever thing can generate your seeds as your random number generator. So all of those are bad ideas. The better idea is create a single random instance, put it into a static field, and then reuse it every time. So basically what you're doing there is you're saying, I'm going to generate the seed once, and then I'm going to extract portions of this random sequence out of the sequence that I have chosen. Or another mechanism is simply don't use system.random if you need random numbers. There are other random number generators in .NET that don't have this problem. In particular, there are pseudo-random number generators that are what are called crypto-strength random number generators, where it is in practice impossible to determine the difference between the output of the random number generator and a truly random sequence of numbers. And those are quite tricky to use right, and I'm not going to talk about them in this course. So here's what I recommend. Right? Here's our best get random array. So we're going to get 10 random arrays here. What does this guy do? I have a private static field that I have initialized here to be a new random object. And now every time through here, I'm going to say, I want the next number in this sequence, the next number in this sequence, the next number in this sequence. But we never reset the random number. We never reset the random number generator. So we're always just extracting more and more numbers from a given sequence, just going through that sequence. And if we do this, then we find out that if we step out here, then we can look at our output and see that finally, this really does look like portions of a random sequence of numbers. All right, so that's how to do correct random number generation, or I should say pseudo-random number generation in C#. How would we choose a number from a list? How would we choose an item from a list? Well, we choose a random number that is an index into the list. So let's suppose, for example, I have a list of pets. I have a dog and a cat and a goldfish, and I would like one of them at random. I can say random.next. Remember, I have this guy stored in a static field, so I can use it from within this code. And I'm going to say pets.count. There are 3 pets in this list, so pets.count is 3. I need an index between 0 and 2, and that's what random.next gives me. So you see how this quirk that you say, I would like the next random number less than 3, actually really does help you here if you're choosing something from a list. All right, so I can say my random pet is, well, in this case, it would be a dog. So I must have chosen 0 as my next random number. You can also extract from the random number generator random doubles. You don't have to just get random integers. The random next double method will give you a double that is greater than or equal to 0 and always strictly less than 1. So if we allow this to run here, then we can see that our output is 0.1, 0.9399, and so on, right? And if we graphed these out, if we did a histogram, then we would discover that it would be more or less a uniform distribution. Your odds of getting a number less than 0.5 are about 50%. Your odds of getting a number greater than 0.5 are about 50%, and so on. The distribution is not perfect, but it's, for most non-cryptographic strength applications, it's a pretty decent pseudo-random number generator. All right, so now that we have all of this gear, we can build some gear for our little Hangman program. So I'm going to step into my Hangman constructor here. And I have added a chooseWord method to our Hangman class. Let's take a look at what that does. I've added a debug assertion here, indicating that we always are going to have words in the word list. Remember, we use debug assertions to say, I believe this condition to always be true, and I'm going to document that by adding an assertion here. If some code modification causes that to ever be false, then this will break into the debugger and produce a dialog box that says an assertion has been violated. It's a nice way to find bugs in your program. So I'm going to assert that my word list has more than 0 items in it. And in fact, it has 172,820 words in it. Remember, I'm using the public domain enable word list for word games. And now we can say, well, I would like to use the random object that I have stored in this static field. Give me the next number that is less than the number of items in the word list, and give me that random word. And our word was, let's find out, moderate. That's a great word. So, summing up, pseudo-random numbers are actually deterministic. They are based on a seed. If no seed is specified, then the seed is chosen based on a timer. And this can cause the same sequence to be generated multiple times if you ask for the same sequence over and over again within the same small time slice. Try to create only one random object or a small number of random objects, because that way you are much less likely to get many of them within the same time slice.